We're excited to have y'all back here for our session on ready-mix concrete carbon budgeting for buildings and infrastructure. We're going to be going through a framework for actionable emission and emission reduction. So we've got a lot of really cool content. I've got a fantastic panel up here that's going to share a lot of great information with you. And so let's get going, let's get started and do that. So who do we have? My name's Corey Zollinger. I'm the Director of Market Development for Cemex. I've got Noah Goldstein. He's the Sustainability Lead for Google. I've got Allison Ken Bennett. She's the Executive Director of Building Transparency. And I've got Amanda Atkinson, VP of Sustainable Infrastructures with Holder. So amongst the four of us here, we've got some, concrete material supplier, we've got an owner, we've got data, right? We've got contractors. So we've got a great audience, I think, that can help answer a lot of questions on how to implement carbon reduction strategies related to concrete in the things that you're building. So I'm going to start off by going through carbon budgeting and the concept of it and some of the challenges that we have with it. And Allison's going to help us with a lot of data behind it and how we can help answer some of those questions. And we'll talk about how we're going to implement that on actual projects with owners. So really cool content that we've got here to go today. And let's get rolling, okay? When I'm done, we'll end up, once all three of us, or all four of us have done speaking, we'll then get into a Q&A session where we can answer your questions. Really, I get a lot of people that are coming up to our booth, talking to me and saying, hey, you guys do lower carbon concrete. And what I tell people is the definition of it is the question, right? We're starting to get a lot of these benchmarks to define low carbon concrete. A lot of requests for what is that and what does it actually mean. And so today I want to go through and talk about specifically how do we start to define that, and especially as we move around the country and see some of the challenges associated with it. Because obviously we want to maximize how low we can go, right? And so if we artificially think we're going low, but we're not going as low as we can, we're not having the impact that we'd like to have. So it really begins by start having an environmental product declaration, right? This is what one might look like for concrete. It's going to explain maybe where that concrete is made. It's going to talk about, the strength of that concrete, whether it's for a cubic yard or for a cubic meter, as an example. And then it's going to report the impacts, the environmental impacts that the concrete will have. Most of the time, we're talking about global warming potential. That's the high point that most everybody's asking about. But if you are curious about some other things like ozone depletion potential, that is also reported in it. But for today's purposes, we're going to focus mostly on global warming potential and what that might mean. So this is really the basics of beginning. When people say, how do I get low carbon concrete? Just start by asking for an EPD, right? That's the very basic thing we can do. It helps us to ensure that we're all talking about the same thing, right? And we're not talking about different concepts, but as long as we've got it dated or we've got it documented, we can see what it is. It's very easy to compare one product against another, right? So just starting with an EPD is a good place to start. But now we start to incorporate this idea. In the past, when we were asked to supply concrete for a project, we would often be asked for concrete that meets certain engineering properties, right? We're going to build a floor as an example. Okay, if we're going to build a floor, it needs to have a certain strength associated with it. It might need to have a certain slump associated with it, air content, that sort of thing. And then we would design that mix and we would supply that to the contractor, to the owner. But now we're also being asked to supply concrete that meets a certain global warming potential benchmark or a certain reduction from that benchmark. And so we've added a new element to what we have to design our concrete to meet. Most of the engineering community, the construction community is very familiar with how to get a 4,000 PSI concrete, right? That's pretty well known. Not everybody knows how to get a 4,000 PSI concrete that also has a global warming potential below a certain value. And that's what we're really working on doing right now, right? If you're thinking, hey, I want low carbon concrete on a project, how might we do that, right? So you're going to build a building as an example. We might set a benchmark value and then set a target. So you've got a benchmark, and then what percentage reduction do we want off of that benchmark? And then we're going to establish that benchmark or that target for each element in your building. Okay, so you've got a floor system, you got a wall system, a foundation, that sort of thing. We combine it all together, we've got our building, and so we're going to start to talk about a budget associated with that entire building and not just the individual elements. So, and now it's got to be realistic, right? It's going to have to be built in a specific location with specific materials. And what we might be able to do with those specific materials might be different than what we're going to do in a different part of the country, right? So where are cements coming from, the type of SCMs that are available, the type of aggregates that are available, logistics, the capabilities of those particular concrete plants all affect what we're actually capable of doing in that particular market. Then you start to look at your specific project. And you may say, well, you know what, I've actually got 20 days before I need to worry about pulling forms, or I've got 3 days before I need to pull forms. That's going to change the type of mix that we're going to need to supply in that particular project, right? So whether it's early age requirements, it's lifting, form removal, maybe we're pouring concrete in the wintertime versus the summertime. All those things affect how the concrete's going to perform. And then we get into other things like strength and durability and exposure classes and all those sorts of things, right? So there's a lot of factors coming into play on how do we come up with a real budget for your specific project. So as you may be aware, the National Ready Mix Concrete Association established industry-wide benchmarks and regional benchmarks to try and help to give us a little bit of perspective in terms of what we can do in different parts of the country. And that's good, but it's also a bit bad because it might mislead us into what is defined as actually low carbon concrete, right? So this is, if you look across the country, these are the values that they established. They were based on different strengths, so a 3,000 PSI concrete in the Pacific Southwest would have maybe a different benchmark value or average value than South Central versus the Southeast, if that makes sense, right? So you can see, as an example, of 4,000 PSI as you move across the country is maybe 247 kilograms of CO2 per cubic yard versus 219 versus 236, okay? So you start to see that regionality matters. So what we did was we took some time to better understand that. Now what's come out is the American Concrete Institute has put out this new framework, ACI 323. It was accepted last year in 2024, and it basically says for larger projects to be defined as lower carbon concrete, it must be 85% of that benchmark value, okay? So this kind of shows you what that benchmark value is. I'll go back real quick and show you. So depending on the size of the building, you know, for the smaller projects, there may not be any requirements. For a medium project, you might have maybe a target, but you know, you may not need to supply EPDs. But for large projects, they want EPDs and they want it to be below the benchmark value. So that got us motivated to understand, well, how hard is this to do, right? And so we, you know, looked at these different regions, but then we started to take the exact same mix design that is used to develop these benchmark values and see how it changes across the country in different markets. So I'm going to show you what that might look like. And so the key here is what when we define low carbon concrete, I talk what those values are in that specific location and application is the issue. Whether you're building a floor slab or you're building a wall is going to change that number. And understanding that is really the critical piece, right? So you can look at, to develop these regional benchmarks, this is the data that NRMCA used. So obviously, you may be getting more data in San Francisco and LA, but maybe not the Central Valley if that's where you're building something, right? So obviously, those are gonna affect some of the results. So at Cemex, we have taken the time to get EPD capabilities at all of our cement plants and all of our concrete plants. It gives us a lot of data that we can start to play with, and we're grateful for that capabilities. So if you look in the Pacific Southwest, this is pretty interesting. This is looking at the 3,000 PSI and the 5,000 PSI benchmark. As we move across the Pacific Southwest with the exact same mixed design, you can see how that number is changing. You might pay attention to certain markets. If you look on the far right, Reno, it actually shows, you know, that the 214, it ranges, you know, from Tucson, Phoenix, Arizona, Vegas, 203 to 210, so it's pretty close. The problem with Reno is that's a little bit wrong. it actually takes an extra sack of cement to actually get to that strength value, so it's misleading here. It would actually need to add about 45 kilograms of CO2 in order to actually achieve that strength, okay? Because the quality of the rock is not so good in Reno as compared to other markets. This is adding some more data. San Diego, Central Valley, same problem, right? The quality of the rock is making it so that it's very difficult for us to actually get to these values. So low carbon concrete in Fresno or San Diego is different than it might be in the LA market. So how are we kind of overcoming that, right? We need better benchmarks, which NRMCA is working on that currently, and we think at the end of this year or early next year, they'll be able to put out new benchmarks with smaller regions so we don't see quite the same variability. So if you're doing a realistic carbon budget, what are you doing? You're looking at the individual elements in your building, you're looking at what you need from an engineering perspective, and then how that material will be placed and finished, and you might start to establish that. The next thing that you're going to do is we're going to ask you to take it and put it into the entire building, not just each individual element, but take that budget and put it into an entire building. Why? Well, as you start to look, this would be an example, right, with different foundations, walls, columns. What you may find out is that it's easier, or we're able to meet the value for, let's say, foundations, but we're going to be too high on your wall system. But when you combine it all together into one, it's easier for us to be below that certain value for the entire building combined, right? And now you're not having the challenges that may be associated with how you might place a wall system versus a flooring system, if that makes sense. So, just to kind of finish off my part of this, the big thing that we've learned in going through all this is really early communication. The earlier you start talking to your ready mix supplier, the better off you are. Historically speaking, you didn't really need to talk to your concrete supplier, right? You didn't need to have those conversations because you knew you could get 4,000 PSI concrete. But as we start to see these projects come about, often we, the concrete supplier, aren't even being told that the owner even wants low carbon concrete. And so we're finding that out at the very last minute, which obviously inhibits what we can do on that particular project. So the earlier we start talking about it, the better those are communicated across the entire chain of everybody involved, the better off this can be. So with that, we're going to turn it over to Allison, and she'll keep it going.
Thank you. That was a great setup. So I am so excited to be celebrating my 1-month anniversary as the Executive Director of Building Transparency. So thanks, Noah, for bringing me into this today. I thought I was just going to get to have fun at Greenbuild this year. This is fun. And I suspect that this audience has used our tools. Can I see a show of hands? Who regularly uses Building Transparency's tools? Excellent. Well, feel free to join me in this presentation. I'm glad you know Building Transparency, and our goal is to help you, once you have a carbon budget, figure out which materials help you meet that budget. So I think you all know that you need your material quantities and you need carbon intensities in order to figure out your project carbon, and EC3 has that data points for you. So let me do a bit of a walkthrough of our embodied carbon and construction calculator for those that are not familiar. So we house information around material quantities from your BIM models, construction estimates, or as-built, and the world's largest robust digital third-party environmental product declaration database. It's free and it's easy to use. It probably could be easier to use, so I am looking forward to learning from all of you on how we could improve. And again, we are supporting finding and comparing building materials based upon supply chain specific EPD data, your project's needs. We help you to plan and compare a project's potential and realized embodied carbon emissions. Manufacturers can show off your great products and their environmental reductions through your EPDs on our site. We audit and verify the EPDs that get loaded into EC3. So Václav did a count. We've added 9,000 EPDs this year We are up to 152K plus, 17,000 building projects have been supported, 65,000 registered users in 84 countries, 6,000 companies with active tool users. We want to grow into the tool that you all need to implement the projects that you have, and I'll be curious for you all to hear more about how Google uses our tool. A great board member and supporter has an enterprise instance of EC3 that they use for their work. So what is the tool? We have a find and compare materials component and a plan and compare buildings component. So let me just do a walkthrough just to give you a sense of what the tool looks like now as we're getting ready to have more detailed stakeholder conversations around what does an EC3 2.0 look like in terms of user interface and functionality. But again, the largest database of digitized EPDs, life cycle stages A1 to A3 for now. Started in North America, but expanding globally and searchable by many indicators. You can scroll through to find the EPDs by product categories per CSI division. We did a screenshot here and did a calculation. We have almost 78,000 ready-mix concrete product EPDs valid in the system now across the globe. Here's a screenshot of the find and compare materials interface. So here you can refine your search for EPDs by performance, by region, what type of EPD do you want, industry average or product specific, and then you can view some statistics for the filtered EPDs that are resulting from the product type that you need. You will then get this box plot diagram. And let me walk you through this in case it's not totally obvious how the box plot can be utilized to help you meet your carbon budget needs. You can see here for the type of products that you're looking for based on performance and region and where your project's needs are. The highest embodied carbon of any EPD found is that max. The lowest embodied carbon is that minimum. And then you can get a sense of the 80% number is EPDs found in that embodied carbon or GWP level are lower than this number. And 20% of the EPDs are found there. So a conservative and an achievable. Then you can see here where the CLF baselines fall in for this product type and compare across your options for the products. And Cemex looking pretty good right there. I made sure of that for this presentation. Yeah. All right, so the plan and compare building projects component of EC3 is where you go and you add your material quantities, importing from your BIM or tally or manually from your bill of materials, and assign EPDs to the project. And voila, I think it's probably not quite that simple. It takes a little while, and we're working on an auto-save function. We heard that at a recent meeting. So eventually you'll get to view your project results for life cycle stages A1 to A3 and or A5 with this estimate through this Sankey diagram. I also wanted to point out, and I know this needs updating because this is such an evolving space, but we do have a policy compliance filter and would love to work with more entities to incorporate those additional filters. Other ideas or input before we turn it over? I guess we'll take questions at the end, but other things you want to talk about EC3 before we go there?
I think the thoughts about how it's going to grow nationally and internationally. People always have questions about that.
How it will grow?
Yeah.
Well, we need to support other parts of the world in standardization, and a lot of other countries are subsidizing EPD development. The federal government is no longer going to do that here in the United States, but I think I'm excited about what IDDI has going on, the UNIDO's industrial decarbonization initiative to work on international interoperability product category rules, greater demand in other parts of the world for EPDs, and we hope to compete with those other databases that might be trying to compete with EC3 as the nonprofit source of EPDs. We are understanding that there is a need for a nonprofit in this space and a desire to continue to grow EC3 through those collaborations and more seamless integrations with other countries' program operators. So I need to have a lot of meetings with other program operators, I think, for that to happen. Yeah. Yeah. Thanks. Noah's turn.
Round of applause for Allison. So I have no slides. So one of the nature, I'm just gonna stand up. The nature of working at a company like Google is getting slides together and approved is a journey in of itself. So I decided to focus my attention and energy on making sure that I can tell a story as opposed to show the story. So you can look at me, not the slides, and I'll hopefully be animated enough. So to be clear, Google has some very ambitious climate targets. The biggest sustainability target we have is cutting our emissions in half by the year 2030 relative to 2019. We have water targets, we have circular economy targets, but it's really the carbon target that takes the cake. And when I say take the cake, that really means we are putting the most amount of money and people into this challenge. And we have a huge team dedicated to energy and scope 2, but when it comes to scope 3, what we recognize is that there's a lot of work we have to do to try and reduce the embodied carbon footprint of our data centers. And just for those who may not know, data centers are indeed growing very fast. The commercial buildings that we're investing in are not really as much of a factor in a company like our size. Other companies have other strategies. It's really easy to say and look at Corey's slides and say, oh, just you come up with a carbon budget and poof, then it goes and there you get it. And so I'm going to both like demystify it and pick it apart a little bit. So the first thing that we need to do is establish what a baseline is for a project. And the nature of how we build data centers is nuanced in that we have a generic design that we then localize to whatever area we're going to be. So you have a generic data center that looks like something, and then when you put it in some place, you put it in Reno or the Dalles, or you put it in South Carolina, it's going to look different. Not only because you have different material requirements, but you have a different site layout. You might have a river going nearby. You might have different kinds of soils nearby. You might have to account for some historical things in the area. So then we have to localize it. And then we take the localized design and we pass it off to a general contractor, who then makes a whole series of decisions about what we actually can buy to meet our incredibly aggressive time schedule. So I'm looking at our one of the general contractors we work with on that aspect of speed. And then we also have to look at what's available. And then we build the data center, and then we try and measure the carbon footprint at the end. So within that process, the concept of a carbon budget is actually, I think, is one we are progressing towards using a lot of the steps that Corey presented, but we're still trying to figure out some of the details, because whatever we do, we have to make sure that the people we work with, our external partners, are incented to do the work or they're getting paid to do the work and what we need them to do. So we are working on our design. We are working on optimizing our design for carbon, amongst other things. That is something that we're doing. Every data center company is doing that. They want to make data centers as nimble for the processing needs they have, as well as account for as low embodied carbon while making them fast to replicate. So that's the generic design. The first step comes in this localization process, where you have your designs and you put them somewhere. You have to what we do is we work with our architecture and engineering firms to establish what a baseline could be, a localized baseline. Increasingly, we are mandating that they use a common set of repository of emission factors of material from places like EC3 to help drive and influence that decision of both what is available in the region, but also what are those numbers. So as Corey pointed out, when you go to Reno, the soils are different. The available materials are different. Therefore, you have to use different kinds of mix-ins, admixtures, as well as concrete. That localization is really key. We want that to be to be blunt, I want it to be fast as possible. We're working with our A&Es now to try and get that. My target is a 2-week process. Who here has done an LCA on building? All right, a lot of hands. Have you ever done an LCA in 2 weeks? Right. All right, here we go. All right, let's talk later. Anyway, it's crazy. There's a lot of detail that goes into LCA. And also, I think that everyone understands that the finer grain detail, you can spend a lot of time in the LCA on what kind of screws and knobs you're putting in and at the local level. What we want to try and do in the carbon budgeting approach is bring in data that triggers, that's associated with the decisions you actually make. So our general contractors are not going to be making decisions really, at this point, on which screws to choose or what windows to choose. Those are decisions that get into our supply chain. But the general contractor, you can choose which concrete to buy, where to source the steel, which admixtures to pitch in, and they would then put pressure on their subs. And so we are putting in place this concept of the carbon budget by doing what I'm calling a lightweight LCA at that localization stage, and then handing those results will be handed off to our general contractors. The general contractors, again, we want them to use tools like EC3 to understand where to source materials, and so that they can then make decisions, and as well as push those decisions down their chain, because remember, they work with a series of subs as well. It all comes back to the general contractors when they are reporting on the embodied carbon. So we have incorporated into our contracts that one of the responsibilities for our general contractors is to report on the embodied carbon footprint of the construction that they're doing. I don't know if other companies are doing this, but we're doing it. We recognize that it does take time, it does take money, it's a learning process, but the best part of that is that the first couple of projects you do, it's a lot of work, and then the general contractor and their subs get used to what they're doing. And one question that comes up frequently is companies come to us and say, someone says, oh yeah, we use this Cemex mix, and we're like, great, and there's an EPD ready to go, you guys are great, you have it all done. We build data centers in rural areas. A lot of the ready mix suppliers may not be as mature and be able to source all of the most common popular materials. That's just the nature of what the business is like. So they come to us and say, what data should we use? And so we sometimes say, if you have no data, use the NRMCA average data, or we say, go into EC3 and come up with a realistic estimate for what that region could be. And so there we actually are having them use that as a baseline, which we know will be higher than which they actually could be using, but that's a start. That information that the GCs give to us at the end is really instrumental in seeing both how we performed on our budget, but also how we can identify opportunities to reduce carbon in our generic design as well. So it's this kind of like full cycle of data that's really important, all being underpinned by good EPD data. That said, you also need to have willing partners in this. And I will say that we appreciate forums like this, organized by people who are willing to work with us. We appreciate there being data partners. Not everybody is aware of what this whole EPD thing is, what low carbon targets are, and what we find is that we just need to keep repeating ourselves. We kind of need to say, this is something we want, this is something customer wants. And so we're gonna hear from Amanda, I guess, from in the field on what that's really like. But I will also say, when people see companies that are doing a lot of development starting to ask for these, what we find is a similar pattern. The first time we talk to them or meet these either a local ready-mix supplier or a local developer or a local contractor, we say we'd like you to have embodied carbon footprint for this design. And the first time they're always not always, but they are we don't know what you're talking about. And that's fine. We tell them, a year goes by, we come back and we say, we'd like you to achieve this level. And they say, well, we don't know if we can do that. We're like, that's fine, just let you know. And then we can come back and say another time, well, we actually are serious this time. We're going to be putting contractual language associated with the carbon budget that we want you to achieve a certain level or below. But we have to work with our partners in a progressive state. And I feel like while climate change is urgent, we need to work quickly on it. We can't change everyone's minds immediately. So I think it's a natural tee off to Amanda to talk about what's in the field really, about working with carbon budgeting.
Yeah, thank you, Noah. I will say that from the contractor experience or side of the house, I don't think we're a unicorn in this space, that we are engaged and excited about carbon budgets and embodied carbon reduction in general. Our experience extends back a little over a decade when we first got involved with our first whole building LCA on Mercedes-Benz Stadium in Atlanta. So we started small and then really appreciated having early discussions with folks at NMRCA who we're ahead of the curve, right? We didn't even know what we were talking about when we sort of leapt forward to the LEED V4 MR requirements and tried to figure this out back in those days. So I think from our perspective, from general contractors' viewpoint, is this is really an area where we can make impact. As Noah mentioned, we don't have sphere of control over everything, but concrete and other key materials that are heavy hitters in this space are things we can influence. And so that's something we've really embraced and love when all the stars align and we can work with great partners like NOAA to further that mission and measure and then also reduce. What we're seeing today, though, is a lot of progress being made by material suppliers in the concrete industry, steel and others. I recently just ran some high-level numbers off of the first national benchmark study with concrete mixes on a national average versus the latest one, and it was about just under 10% reduction, right? So some of that is obviously from better measurement, but I think there's real progress being made. Obviously, it's different and varies in every area, and I think I just saw a headline from the steel metric that it's about an 11% reduction since they started doing an industry benchmark. So progress is being made, and what we see is really today is a bit of a process problem where the opportunity is there. What we're doing today on a lot of our projects is a little bit of a stealth operation, and I wish it didn't have to be like that. Our starting point is to first go to our concrete suppliers and have this conversation so that it is daylit early at the beginning of the project. Sometimes we're not even telling our clients we're having these conversations because we know the potential and the opportunity is there. So we sort of work behind the scenes to maximize the opportunity for reduction without any cost and schedule premiums, and then just show them, sort of at key touch points in the project to help smooth that barrier and not sort of be part of the stopgap that comes when it gets to a contractor and, the cost and schedule barriers are hit. So again, I recognize that not everybody is there yet, but I think we are trying to do our part to send the right market signals as well to the suppliers and the trade partners that we work with. We have, contractual language built in, and we're sending signals that way into all of our key subcontracts today. And again, what we've seen is really good success, and we're going to keep doing this. Just as an example, again, another project in Atlanta recently, we're building a big parking deck for the Atlanta airport. And right now that project is tracking to finish 6 months early and have an over 30% reduction in the concrete embodied carbon. So you can do it. It doesn't slow the schedule down, right? But it has to be a project by project study. And again, each product type, each area is different, but that's where we're really bringing, not waiting, right, for the submittal process to happen. We're really bringing that process forward ahead of award and making it part of early market engagement and those early conversations, because that is the shift that needs to happen. The appetite is there from the industry. It's the process shift that has to happen to study those things earlier in order to prove the point. But at some point, we're not going to have to prove the point because it's just going to be the baseline case, the base way we all do pre-construction and set a job up for success. So yeah, that is some of what we are seeing and ways that we have really appreciated great partners like Cemex, and certainly we leverage EC3. We are documenting all of our current projects in EC3. Those that some of our clients ask us to do, but those that we're doing voluntarily as well. So we really appreciate the tool and are excited about the next steps. But yeah, I think that's all I have.
Yeah. I have a question,
Yeah.
comment. One of the things that I find attractive about the concept of a carbon budget is that I want to set the target as an owner. I want to set the target, but I want you to figure it out. And so, is that overwhelming? Is that empowering? When we say things like that, how does that hit you?
I love it. I don't know if everyone would have the same reaction, but I think, again, it empowers us with less limitations to provide a solution. And that's sort of what we're all saying, right, with performance specs for concrete. We want the freedom to, have a target of a certain percent reduction, whether it's the 15% that you mentioned earlier, Corey, or something more substantial than that. And I think something you touched on as well that we see is really a pathway to success. There's a lot of specs out there, right, for concrete. There's a lot of different versions of people trying to put this in words and write this down. I think definitely the volumetric and total project sort of reduction is very appreciated, so you can look at different elements in the appropriate way. And so that's what I think we really appreciate when we have that freedom, and we have the structural engineer and other design team members bought into that sort of case in the way that we would approach that carbon budget.
I was going to say, man, you brought up one topic that we didn't get into much, but that is specifications. We're working, as an example, with the City of Austin. The City of Austin has started to ask for EPDs for their mixes, and they want carbon reduction. And we told them, your spec is so far out of date that it is impossible to actually make any real impact. You're going to ask for EPDs, we're going to spend the money to give you EPDs, but we're not going to actually be able to do anything, right? So I think that's another conversation that we really need to have amongst all of us, is how do we incorporate more performance-based specs that allow for this innovation and allow us to get a lower number so that the Googles of the world are happy. I don't know how much you've run into that, but yeah.
So we've been spending a lot of time in upgrading our specifications, and there are three major things that come out of that. First is, as you mentioned, Corey, which is a really good point, we find so much technical debt and must or crap in specs because they simply it's like a game of telephone that just keeps going on and on and on and on. And so when we start looking at them, we're able to just streamline them. So that's just one thing that happens. It just makes them a more efficient document. But then we both include carbon limits on materials, not just on carbon, but on steel, and getting to some other materials as well, that we then pass over to the A&Es and then the GCs to implement. But we also now establish a reporting spec too, that ensures that we are actually getting the data we need and that people are receiving the information in a constructive way. So it's this is another way of leveraging a spec as a lever, that we say, give us the data, the EPDs, report in this way, use tools like EC3, and therefore it's not ambiguous, it's mandated. So I don't know if we're going to have to...
Yeah, I was just going to touch on, a couple of things about specification. Now I'm losing my train of thought, but I agree with Corey that and Noah that we see a lot of barriers in those specifications that are contradictory to an overall, volumetric reduction goal, and so it's really important, I think, in a piece that's part of our process as soon as we recognize and validate sort of with local suppliers that there is opportunity in the area, either by looking quickly at the EC3 database or, oftentimes paired with reaching out to, the local suppliers. More so than having specs with barriers. What we see is there aren't any specs. And so I recently just did a quick study of our book of business for this current year. And about 80% of our clients are asking us to measure sort of the end, actual numbers. So the as-built numbers. We are measuring 100% of those, so we're making up for the gap. Only about 15% of our clients actually are asking us to reduce. So I'm sitting on stage with one of those. But less than that, even less than that, actually have it written down somewhere. So in some sort of OPR or specification, an email, there's just very little leverage that I sometimes have to go to my teams and say this is real. And so more of specifications in general would be great. And then we can help, iterate and smooth those out with an owner working with the best practices and lessons learned over time. But we are seeing, again, more and more structural engineers understand how to sort of formulate those specifications the way that the market best responds to them. But I would advocate, in addition to getting the spec right, just get started on your projects with those.